Before we start on our next lesson, you notice that there's a map, and it's a map of East Harlem. So if you were to find Cristo Rey, we would be in, oops, let's try to do this again. We would be in this area, so where the dot is. Okay, so why are we looking at a map? Notice, so you should ask yourself, what is it about this map that I need to be focused on? What do I notice? If I were to look at it, or anyone look at it, you can notice many different things. You notice the Harlem River Drive, that's in red. You see the Triborough Bridge, that's in green. You see the park, certain parks that are in green. Look at the streets. What do you notice about the streets? If you say that they're in grid formation, they're going up and down, the avenues go up and down, north and south, north to south, and the streets are going left to right, east to west. Notice how the lines that are created, the lines that are created, creating the streets, they are all intersecting each other. So with these lines, this will lead us to the lesson that we're going to be learning about. And if you guess about parallel lines, perpendicular lines, then you're on the right track. So our lesson is dealing with parallel and perpendicular slopes. And the objective is, how do we define parallel and perpendicular lines, and what is their relationship with their slopes? So just looking at the New York City map, there's a relationship between the lines, our streets and our avenues. And we're going to learn what the relationship is. So when it comes to parallel line, the definition is two lines in the same plane that have no points in common. So basically, parallel lines, they never meet. They're going in the same direction, but they're never going to cross each other. And based on the notation, you got the two lines, two vertical lines, means that it's parallel. So when it comes to parallel lines, let me just see if I can expand this. Oops, let me try that again. Okay, so it says find the slope of AB. So we get the line AB. Again, remember about finding slopes. You could take the 2 points, A and B, and then use the m equals y2 minus y1 over x2 minus x1. But when it comes to a graph, all we need to do is find rise over run. So for slope of AB, and I'm going to put MAB, so that way I can distinguish between these two. This would be CD. So for this one, I'm going to do rise over run. So from B to, actually, yeah, from A to B. So I go 1, 2, 3, 4. So that's 4 down. And then 1, 2. So that's 2 to the left. And you know, negative divided by negative is going to give you a positive. So 4 over 2, and then that's a 2. For CD, which I'm going to use another color, which I should have done for this, so let me just trace over it. So it's going to be 1, 2, so it's 2 down, and then 1 to the left, which is negative. So again, if I were to simplify, that'd be 2 over 1 equals 2. Sorry about the watermark, I can't get rid of that. So now, it says, what do you notice? What do you notice about the two slopes? If you said that they have the same slope of 2, same slope of 2, then you are correct. So we just proved that these two lines are parallel. So with that being said, If you have the same slope for 2 lines or 3 lines or 4 lines, they have the same slope, that means that they are parallel. So same slope, parallel lines. Okay, let's go to perpendicular lines. So let me use another color. So they say find the slope of AB. So I'm going to put M and then AB. So let's look at AB. Again, I'm going to do the rise over run. So A, go 1, 2, 3, 3 up, that's positive, and then 1, 2, 2 to the right, which is positive. So it's 3 over 2. Now I'm going to find the slope of CD by using my rise over run. And let me try to go. Okay, good. So for C to D, so I got 1, 2, 3, 4, 4 up, and then I'm going 1, 2, 3, 4, 5, 6 to the left. So if I were to reduce that, that would give me 2 over negative 3. All right, question is, what do you notice? Look at the two slopes. This one says 3 over 2. This one says 2 over negative 3. If you said that the fraction, the numbers switch positions and it became negative, yeah. So this was 3 over 2 and this one's 2 over negative 3. It flipped and it became negative. So the slope, um, I would say, actually, you know what, let me remove that one. So one is positive and the other is flipped and negative. And there's another way to describe it, and that is called opposite reciprocal. Reciprocal, yes. That's another way to describe that. Opposite reciprocal. Alright, so let me go back before we do an example. So basically, with parallel lines, in order for the two lines to be parallel, their slope has to be the same. In order for two lines to be perpendicular, they have to be opposite reciprocal. That means, let's say if you have 2, the other one has to be negative 1 over 2. If they're opposite reciprocal, then the lines are perpendicular. If they have the same slope, then they are parallel. Alright, so let's do some examples based on this one. They say graph the quadrilateral ABCD and then show by means of slope that the quadrilateral with the vertices that's given has 2 pairs of parallel sides. So let me plot this one. So this is 2, 1, that's A. Then 4, 1, 2, 3, 4, negative 2, that's B. And C is 4, 1, 1, 2, 3, 4, 1. And then D is 2, 4. 2, yeah. 2, 4, 1, 2, 3, 4. To make sure I have everything correct. 2, 1. B is 4, negative 2. C is 4, 1. And D is 2, 4. Okay. I'm going to use my line to connect this. Yeah. Okay, so that's our shape. Alright, so now we need to know if they have 2 pairs of parallel lines. So we're going to look at Let me make this clear. I want the A. It looks like the A is sharing the same point as C, but it's not. This is our A. All right, so I'm going to look at DA and CB. So the slope for DA, I'm going to do, actually, what? It's a vertical line, so I'm not going to use that. So let me use DC, and then I'm going to use AB. So let's do the rise over run. So D, to get from, let's see, D, we got 1, 2, 3, 4, 4 down, and then 1, 2, 2 to the right. So that gives me -2 for the slope of DC. And let's do AB. Let's go 1, 2, 3. Oops. 1, 2, 3. And then 1, 2. I want to make sure that I plotted everything correctly. 1, 2, 3. 1, 2, 3, 4, and then -2. Okay. And C. Again, double checking myself, making sure that 1, 2, 3, 4. Yep, I made a mistake somewhere. I mean, the graph is tiny, so it's going to happen. So that I went 1 too far. All right, so let's do that. So that one should have been 1, 2, 3. So this one should have been -3. Again, that's why I got to be careful with plotting. And then this is 3, and that should not be -2. Okay. So that should be just -3/2, and then this one's -3/2. All right, so by looking at the two of them, notice that they're the same. So then yes. So we've proved it. So yes, parallel. Because same slope. So yeah, so that's how you would prove it. They give you a shape. You would do this. You would use you give you the shape, find the slope of two lines to determine if they're parallel or not. Right. So same thing with this one. So we got to plot our points. This is to be a triangle. So we got 0, 2, and then we got 2, 3, 1, 2, 3, and then we got 1 and 1, 2, 3, 4, 5, which is C. And I'm going to connect those. So that's AC, CB, and AB. All right, so they want to know if it's going to be a right triangle. So if you know anything about right triangles, you know that the two lines have to be perpendicular. If the two lines are perpendicular, they create a 90-degree angle. So I'm going to be looking at the slope of CB and then the slope of AB. Because I'm looking at it and I see that it looks like it could be perpendicular, but I'm not sure unless I prove it. So let's look at the slope of CB. So 1, 2, 2 down, -2, and then 1 to the right, so that gives me a -2. And then let's look at AB. So that's 1 up, and then 1, 2. That's a half. So let's see. This one tells me if I'm going to circle it so that way we know what we're looking at. This one says 2. This one says a half. You know what? This one has been flipped, the reciprocal, and it became the opposite reciprocal. So then yes. So that means I'm going to write So AB is perpendicular to CB. So yes, triangle ABC is a right triangle. Yeah, because it gives you that 90 degree. And I'm going to put a little marker there. That means 90 degrees. It's a right triangle. So that's how you would apply this, finding the slope, whether it's perpendicular or parallel, to determine if the sides of a shape is parallel or if it's perpendicular to each other. All right, let me see how far. Okay, I got a few more. So for this one, it says use the slope to determine if AB is parallel to CD. So I got this AB and then I got CB. I'm going to use different colors. All right, so let's start with AB. Let's find the slope of AB. Since we don't have a graph, we have to use the slope formula. So for the slope for AB, it would be y2 minus y1 over x2 minus x1. And I'm going to label so that way I do not get things mixed up. Get into the habit of that. So this would be 9 minus 5, and then 3 minus 1. This gives me 4 over 2, which is 2. Now I'm going to do the slope of CB, and I'm going to label. So I got x1, y1, x2, y2. And then I'm using my slope formula. y2 minus y1 over x2 minus x1. And it would be 6 minus 2 over 4 minus 2. This would be 4 over 2. And this gives me 2. Look what I see. And let me put this in purple. This is 2. This is 2. So, yes, AB is parallel to CD because same slope. Same slope of 2. There you go. That's how you prove if something is perpendicular or parallel based on their slopes. Alright, the last one is a challenge. It says in the following set, select the one equation whose graph would not be parallel to the other two. So we've got 3 different ones. We got this, we've got this, and then we've got this. Alright, so now in order to figure out which one is not going to be parallel, we have to focus on the slopes. So for the first one, we got y minus 6x equals 3, and I'm going to have to put it in the slope-intercept form. Remember, it has to be y equals mx plus b, so that way you know what the slope is. So that means I'm going to add 6x on both sides, and get y equals 6x plus 3. So that's my equation for this first one. The second one, I have to do that too, put it into the y equals mx plus b form. So I need to have y by itself. I'm going to divide 2 on both sides, and that gives me 6x. That's for the second equation. And then for the third equation, it says x equals 6y. I need y by itself, so I need to divide 6 on both sides, so y will equal 16x. Alright, so let me do this so we can look at each differently. So different colors. Alright, so then which one would that be parallel? This. And if I could highlight it to show. So notice that this and this has the same slope. but this 1 over 6 doesn't. So then 3, which is x equals 6y, would not be parallel to the 2. So I'm just going to write that out. Put that in black. So I'll say x equals 6y is not parallel to y minus 6x equals 3 and 2y equals 12x. Okay, so we've reached the end, and I'm just going to do a recap. We learned about parallel and perpendicular lines. So basically, parallel lines are two lines that will never intersect. And when you have to find it on the graph, if two lines are parallel on a graph, look at the slope. If the slope are the same, then the line is parallel. With perpendicular lines, that they intersect at a right angle. That's mean right angle means 90 degrees. Again, you got to look at the slope of the two lines. And if you have opposite reciprocal, that means one of the fraction is reversed and it's opposite, whether by it's either positive or negative, then it is perpendicular. And you could use that to apply, especially with shapes, to see if the lines are parallel or perpendicular. And this goes back to what was shown in the beginning with the map. If you wanted to know if Madison Avenue is parallel to Park Avenue, you would try to find the slope. And the same thing, if you want to know if Park Avenue is perpendicular to 106, you would have to find the slope and see if it's the opposite reciprocal. All right, so this concludes our lesson for parallel and perpendicular slopes. If you have any question, whoops, going too far ahead. If you have any questions, email me and I will help you out. All right, have a good day.